Continue. Okay, so we'll just start off with looking at the important terms for Chapter 5. Valkyrie, since you're the only one here, I guess I'm just going to be talking to you, asking you questions, because there's no one else here. Can you see my screen that I'm sharing? It says I am, but also my camera has me on it, so I don't know. You know, can you tell ever? Like, is that what they see, or do they see me sharing the screen? Because it says I'm sharing the screen right now.
I usually, when I have, like, during a test prep, I'll set up my laptop.
Oh, and watch it.
Just so I know for sure what it is.
Okay.
And then for the chat.
Okay. Well, Valkyrie, you can just type in any letter in chat if you can see the screen that I'm sharing that has the Chapter 5 terms on it. If you can't, let me know. Oh, okay, cool. She can see it. So I didn't know I could do that because I'm standing here looking at myself and then, but okay. Anyway, Chapter 5, important terms. First off, of course, we'll just start off with thermochemistry because that's what the whole Chapter 5 is about, which I don't know if you want me to read them off to you or not, or we can just look at them. These are just some of the basic things that you need to know in order to do changes in enthalpy and then thermochemical equations. Yeah, and especially know the difference, especially between endothermic and exothermic processes and any kind of question that asks that, which is pretty simple. I always do like EN reminds me of in for like inside, and then EX is like exit. So I just do inside and outside, or exit and enter. Oh, that's how it is. EN is for enter, so it's inside, and then EX is exo, which is exit. That's what I always say. But that tells you if the heat is being absorbed, which is endo, and then exo is where the heat is released. That's the difference. Released and exit, and then absorbed and enter. That's how I remember it. Any questions? Crowd. Large crowd that I have. Okay. There's other things here that are important. This Word document's also on the website, so if you need to review this or look it over anytime, you can. You just go to the website. Hopefully, you know what that is. I've plugged it in to many class times and emails, so there's that. So look over this. Do you have any questions, Valkyrie?
Not at the moment.
Not at the moment? Okay. I guess we'll just get into, because she kind of already went over this stuff, so I don't want to go too deep into it. And we'll just go into an equation that I found and printed off. Now I need to go to Wolf Vision. I think that's the one with the, right?
That works, but that's not the best way to do that.
What? This? What do you mean? No, I just stopped sharing, right?
Yeah.
Don't I just share screen?
That'll work, I guess.
How do you?
How I do it.
Oh my gosh.
There's a stop share. It's right. Let's blow into it.
This is how I do it. How do you normally do it?
You can share screen,
Okay. Boom.
advanced. There's at the top. Content from second camera all the way up.
Oh. And you just share that?
Yeah.
Instead of going to the.
Zoom in on me so they can see me talking because I talk with my hands a lot.
Oh my gosh. Oh my gosh. Whoa, what's happening? So I did it right.
It's because you already have it on.
I already have it zoomed in on me? Yeah, and for this camera, I don't think there's a. That's as close as it gets. I fiddled with it before, so I know now. What? No, I know it didn't move very far, but it's okay. Oh,
But
sorry.
now it's in the small screen. So go to your video again.
Oh, yeah, I see what you're saying. And it'll flip them. Oh,
Well, now you have to screen share.
what? It's because you did something. Wow, I'm learning so much.
It's just a lot of work.
Yeah, it's also a lot easier. I didn't know that you could have your camera on. Like the first time I did this, I did it to where like this was on my screen here and I couldn't see anything. It was just this. And so I was like trying to reference something on my screen. It was crazy. It was bad, but yeah. So first enthalpy equation that we'll go over. Enthalpy is the change in heat. So there you go. The combustion of methane, which is CH4, releases 890.4 kilojoules per mole of heat. That is when 1 mole of methane is burned. So that means that 890.4 kilojoules are given off to the surroundings, which is one of the terms on the worksheet that you can view. This means that the products have, I have to say this so many times, 890.4 kilojoules less energy stored in the bonds than the reactants. So that means it's exiting. When it goes through, the combustion of methane happens and it reacts. That means that this amount of heat is released out of the system, which is what we're doing. So now it just wants to ask us how much energy is given off when there are 2 moles of methane. So when there's 1 mole of methane, it's that much. But now it's asking about if there are 2 moles. So the amount of methane changes, which means that our amount of energy released is also going to change, which is super easy to calculate if you just want to follow along. My one student here. We got our 2 moles. And we start off, we go boom. And what we want to find is obviously how much energy is given off from our 2 moles. So we got our 2 moles, and then we have how much energy is given off from 1 mole. So we put that up here. Make sure I write that down right. Put our little kilojoules, which is our unit of measurement for heat. Then we get 1 mole down here. Oh, that's an N. So obviously our moles we're going to cancel, and we're going to get how much heat is going to be released into the surroundings. Which, if you had a calculator, you type it in real quick. But I don't have a calculator on me. Normally when someone's here, I just ask them. No, it's right here. But yeah, thanks for asking though. Really? Well, I loaned mine to one of my friends because they're in a pre-cal class. I'm like, I don't have a math class really. And I was like, I'm in OChem, so I don't need it. But that's how much heat is being given off when we burn our methane. And so a good thing to know when you're doing enthalpy equations, the negative symbol is exothermic. So when there's a negative, it's being released, and when it's positive, it's being absorbed. So negative is exothermic, and positive is endothermic. Okay. So far, so good, Valkyrie? Since you're
Yes,
the only
the
one
only
here.
question that I had was my calculator gave me 1780.8 kilojoules.
Okay.
Would I round it to 1781 or would I leave it at 1780?
So for what I'm doing, I'm just walking through how to calculate it. When you do your exams and your homework, which I believe is on Newton, sometimes it'll ask with the correct amount of sig figs, or it'll be specific on each question and say to the hundredth place, or 2 sig figs, 3 sig figs, 4 sig figs. It just kind of depends most of the time. So you just follow sig fig rules unless it asks for a specific amount of sig figs. Like most questions on homework, because I've done my homework on Newton for Chem 1 and Chem 2, and it was like 2 sig figs, 3 sig figs, and that's normally what you get. Sometimes there's 4. But that's usually how it is. Does that answer your question?
Yes, thank you.
Yeah. So you'll have to be specific with your homeworks and questions your professor asks. So it is good to practice that. I'm just not specific because I don't need to be specific, but that's how it goes. So yeah. So we've done part A and you're all good with that. So now we'll just go to part B, which is we're changing, or we have a specific amount of grams of our methane. So now we started off with 2 moles, which was easy because it already gave us what happens when 1 mole of methane is burned. And now we know what happens when there's 2 moles of methane, but now we're in grams. And so I don't know if you've been here in my earlier SI sessions, but basically the first part of this is we're just going to convert from grams to moles, and then we'll have our same problem. All it's doing is adding an extra step, which is what most of your homework and stuff does. It'll give you grams and ask for you to do the equation or go through the reaction, and you'll end up having to convert to moles. That's what most of the homework and quizzes are like, especially on Newton. I don't know about Professor Hakiki. So we'll just do our simple converting at the beginning real quick. Bada bing, bada boom. And we want to go to moles, so we'll put our moles up top. Basic chemistry stuff. And we know, then you got to find your molar mass of CH4, which carbons is 12 point, whatever it is, 12.011. I used to have that memorized, and then we have 4 hydrogens. So I'm going to round mine to 16 grams, but if you put it in your calculator, you can just do, for your molar mass, you can go like 12.011 plus your 1.008 and multiply that one by 4. So because there's 4 of them, and then you would get your specific number. Because whenever I did my homework and exams, I always used the numbers as specific as possible, and then I would go to my sig figs, which if we did a sig figs on this one, it would just be, there would be 3 significant figures. So that's what I always do. But for how I'm doing it right now, I'm just going to go with 16. And so then you basically go boom, boom, which you multiply that. And then we need to go. So now we've converted from grams to moles, and we're going to keep going. I'm not going to write down the little answer because I'll just write it all out in one conversion line. And now we want to go to how much is burned. So we need to calculate how much heat is released for our exothermic reaction. So we'll start off with our 1 mole. And so those cancel. Oh, I got to write that out. Boom. And see what happens. We'll do 22.4 divided by 16, and then that number we'll multiply it by our kilojoules to get how much heat is released, which if you want to put that in your calculator, Valkyrie, and tell me what you get before I write down the answer.
I got negative 1,243.2 kilojoules.
Perfect. So we got our negative sign because it's exothermic. And so you said 1,243 yada, 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 which is correct. My answer is rounded, so, but you're right. Sounds good? I'm assuming.
Yes, thank you.
No problem. Do you have any questions? And if not, I'll just go straight on to C.
No, I'm good. Thank you.
Okay, cool. It's kind of weird talking to people because they're just like, so like, where do you look when you ask them a question? At the camera, but yeah. Okay, so for our third problem, we'll go over it right here. I'll read it off to you. If you were to attempt to make a 45 gram of methane from CO2 and H2O with O2 also being produced, how much heat would be absorbed during the reaction? Okay, so basically what is happening is they've just written out our equation, or our reaction in word form, and we got to find out what our reaction is, because in the first part, they gave us the reaction up here up top. And so now we need to create our reaction with what they've provided. So what's happening is we are making 45 grams of methane from CO2 and H2O, which is basically going to be the opposite of what is happening. Can you see that? Okay, cool. Which is going to be the opposite of what's happening in this reaction. So what's happening is we're taking, this is the reaction they've given us, but now we're using the reactants to form the products. So I'll write that out real quick. If you want to, I guess if you have paper in front of you, you can write it out real quick while I'm writing it out, but if not, just follow along. So you get your carbon dioxide, plus your H2O to get your CH4 plus O2. Now, if you look quickly, we're going to have to refer to one of the previous chapters, just like we did with these first two questions, and we're going to need to balance our equation because there is only 2 hydrogens on this side and 4 on this side. So we need to figure out how to balance our equation, which this is a fairly simple combustion reaction, or the opposite of combustion reaction. So we just need to balance out our hydrogens. So we have plenty of hydrogens, but now we have 2. So we have 4 oxygens on this side now. So we're just going to need to put a coefficient of 2 in front. So now our equation's balanced. We can work off of it. Sounds good. So since we are making our methane and it asks how much heat would be absorbed during the reaction, a question for you, Valkyrie, is absorbed endothermic or exothermic?
Isn't it endothermic?
Yes, it's endothermic. So that way when we get our absorption or releasing of however much heat in our kilojoules, it is going to be the same thing but the opposite because we're absorbing it. So we're going to put make sure that's on the screen. Our little symbol. And since it's being absorbed, it's going to be positive. So you can put a plus sign or just leave it the way it is. It varies from question to question and material to, like, I don't know if Professor Higigi wants you to have the plus sign or not. It just depends on who you have. But I'm just writing it down so you know that it's positive because it's being absorbed, which makes it endothermic. Cool. So now we have our reaction. We have the amount of heat being absorbed. We need to find out because we have our 45 grams to make our methane. So we need to go from grams again to moles, just like B. And then we need to go from moles to how much heat is being absorbed in this case, because the other one was being burnt off and released. Make sure I'm writing on the screen. So if you want to go ahead, Valkyrie, and do this question C, I'll just let you know, it's going to be pretty much the exact same as B, because we've finally set it up now. So yeah, I'm going to slowly write it out, but if you want to write it out before me and see if you get the correct answer, you can go ahead and do that. I'll let you have time for some independent practice. You know what? Something I forgot to do was to bring water. The first SI session I had, I talked like the whole hour almost. It was crazy. And I had no water. I was like, you guys can do this problem. I need to go out there and get a drink of water. Huh? No, it was just a regular old session. No, they're going to have their... Actually, this is a question I'm going to have to ask you about. Yeah, look at that. Cool. Do quick math in my head. Yeah. So if you write out your reaction, I'm going to drag that out of here. Oh, that'll make it big. Okay. Sorry. This might be easier. I keep bending over this thing, but really? Yeah, it's like, you must have picked the right room. I didn't even think about that factor for picking a room, but okay. Right. Back to our equation. We're going to start off with our grams. Make sure I'm writing on the screen. Get this out of here. Okay. Writing on the screen, 45 grams. And we're trying to make our methane. So put our methane, because that's what we're finding. And we're going to go with, boom, finding moles. And then we're going to use our 16, or to be more specific, you would use your other molar mass. Boom. And we go to use, put a plus sign because we're converting to kilojoules now. Boom. Which gives us our answer. I'll put your answer on there because it's the more specific one. Just because mine's rounded, but you were correct. There you go, kilojoules. I always put commas. Some people don't, but yeah. I know. So you look at that, and I'm like, why does that number look so weird? And then I go, oh, okay. See, look, I didn't do it up there. Yeah. So far, so good, Valkyrie?
Yes, thank you.
No problem. Other than that, all that this worksheet has is there's extra practice problems that you can go over, which, I mean, it's on the website, and you can go on and download the PDF and just follow along with it. The PDF also has the answers, so just make sure you work it out, and then you can double check yourself. That's for practice sake. But if you don't have any questions, and since you're the only one and we've got it all following along, that's all of the material that I'm covering today, just because we've only just started the chapter. So.
Okay, awesome. I do have one question. Are you going to have any test review on Wednesday, or is it just going to be chapter 5?
That's what I'm going to try and talk about and see if I can get an extension to 2 hours, because normally the SI or the test preps are 2 hours long. But if it doesn't work out, because I don't know how long you have to have that requested for. We'll just do the 1 hour Wednesday session, but it will be test prep. It'll be all test prep. But hopefully I can get it to 2 hours so we can cover more and review. But yeah,
Gotcha. Thank you so much.
no problem. Also, if you bring questions to the test review, it'll also help just because I don't know exactly what you're struggling with going over it. I'll just have some of the broader material that I've covered, but if you have like specific questions that require something specific, like I had one student, we had to go over parts per million and parts per billion, and I had to brush up on that because she only went over it for like 5 minutes. So, but yeah, if you have any specific questions, bring them for Wednesday. And that's all I got. I don't know. Is anything else? Do you have anything? Huh? Attendance? Oh! Well, normally I do that, but I just jumped into it. Do you have a question, Valkyrie?
No, I was just gonna say, I guess, bye if you're gonna end it.
Before you go, can you go to the website and then click the sign in button and just fill out that information? I think it's your UID number, your name, and your professor. If you fill that out for me, I need your UID number so I can put you in that you came here. So,
Perfect.
but other than that, that's all I need. So, if you do that for me, then you're free to go. Do you know how to get? You know how to get to the website, right? Just making sure.
Yes, I do.
Okay, perfect. Yeah, just go ahead and do that and then scroll down to the links button, or it might even be before that, the second page, and you just click the sign in button and fill that out. So yeah. Other than that, have a good one, and I'll see you Wednesday. So how do I stop recording? Or stop recording, and it'll save it, I'm hoping.